Starting with version 12.131, a professional license of EES can be called from other applications using the FindWindow and the SendMessage commands in the Windows operating system. EES will respond to a SendMessage command that has the following format that's shown here. So the first parameter, hwind, is the Windows handle of an open EES program. The second parameter, this run EES, is an integer message type that EES is programmed to recognize. So you must set it to 32777. The third parameter, command, is an integer that specifies what action you'd like EES to take upon getting the message. And the choices for the different actions are listed here below. And the first three options correspond to manipulating a log file that logs the commands that are executed during the process, and this log file is really useful for debugging purpose. The log file is maintained in whatever folder you've installed EES in, and it's called EES call from app.log. So the first one here is 0, which is delete log. That'll cause EES to delete the log file, so that's useful if you want to start writing it over instead of appending the commands to the existing log file. The next one is a 1, which would be given the code log off, and that turns off logging if you don't want to log the commands to the log file. And then a 2, which is log on, that creates the log file if it doesn't already exist, and it starts logging to the file. And then the last two options here are telling EES what action to take, and there's only two of them. And the first one is 10, which is solve, and that just says solve the file that's open in the EES application. And then 20, which is run macro tab, would run a macro tab that's open in the open EES application. And the macro that's going to run will be the one with the tab number provided by this fourth parameter extra. So this parameter extra should be set to 0 unless you're using this run macro tab command, in which case you'd set it to a number corresponding to the tab you want, the tab that contains the macro that you want to run. And this send message will return a value to result, and if result is 0, that says that there was no problems, there's no errors. Otherwise, result will contain a string that will be displayed to tell you what error was run into during this process. So the window handle corresponding to EES can be found by using the FindWindow command, which is shown here. So the parameter here, TES_D, says go look for a window that corresponds to the EES application. Right? And this approach keeps EES open and ready to respond to commands that are issued by the calling program. The passing of data to and from EES can be done using data files, and the whole interaction then is relatively fast, as EES does not need to restart before each command. This approach will work for any application that can issue these Windows commands. Here we're going to illustrate the process using Excel, but it's going to work for other programs like MATLAB or Python or LabVIEW or all of these kinds of programs. So let's do a simple example here where we will call EES from Excel, and we'll just use EES to calculate a thermodynamic property. So here I'm going to start Excel, and in order to get to Visual Basic, I'll click the Developer tab. If it's not already available in your version of Excel, you may have to right-click in the menu space and add it to the ribbon. Then I'm going to select Visual Basic from the Developer tab in order to access Visual Basic here, and I'll select Module from the Insert menu in order to create a new module. So there is a .bas file available that includes some useful declarations and utility routines that will make your life easier. So I'm going to go ahead and import that so I have it. These files can be downloaded in the zip file that is linked in the description of this video. So you can get this BAS file, and you can also get all the other files that are involved in this example. So you can see here the file includes in the header region the declarations of the send message and the FindWindow functions, and as well as these useful constants that are declared to encode the parameters that have to be sent to EES. And then there's a couple of handy utility functions that are included here to delete a file and to check if a file exists. So I'm going to write a function called volume, and this function is going to take in a string which specifies the fluid, and then two numbers, so two doubles that specify the temperature and pressure. And the function volume is then going to return a number, a double, that is the specific volume at that state, calculated from within EES. Because we're going to communicate using data files, I also have up here a string called folder that contains the path to the folder where we're going to write these files. Within the function volume, the first thing that we're going to have to do is write the information, so the fluid, the temperature, and the pressure, to a file that EES can then open in order to gain access to these input arguments. So this is going to be done in a subroutine called setInputs. So let's write setInputs. So the first thing I got to do in setInputs is surround our string with single quotes, so that it's going to be recognized as a string by EES, because EES requires strings be surrounded by single quotes. So let's build a temporary string RR. So we'll declare it, and then we will form it by adding a single quote surrounded by double quotes to its beginning and its end of the string R. So it's not super convenient, but it has to be done so that EES recognizes this as a string. And then the file state.dat within the folder that we're going to use for communicating is opened for output using the open command, and these quantities RR, so that string that specifies the fluid, and TMP, so those two doubles, are written to the file, and then it's closed. And one of the great things about using this approach is that it's pretty easy to debug what's going on with Excel or your application, and then also what's going on with EES, because they're both going to be up and open, and we can sort of make sure that the process is working as we go through it. So here I'm going to go right ahead and test that this is working up to this point. So in the Excel spreadsheet, I'm going to set parameters that include the fluid, so maybe R134A, and the temperature and pressure in Celsius and kilopascals, and then I'll call the function for volume just the way that I would call any other function in Excel. And you can see that when it executes up to this point, if I go look in that folder, there is a file called state.dat that contains these parameters, and it's just waiting here for EES to open it and continue the process. So I guess now we'll jump over to EES, and we'll build an EES program that reads this file state.dat that we just wrote from Excel, and then it needs to calculate the specific volume at the temperature and pressure and for the fluid that we specified, and then finally write a file containing that specific volume. So there's a few ways to do this, but what we're going to do here is use the $import directive, which will be executed first, and it will open the file and import those three parameters. So in order to calculate specific volume, first we got to set the unit system, so temperatures in Celsius, pressures in kilopascals, and then we'll calculate V using the volume command in the usual way. And then finally we will export this number using a $run macro after directive. So $run macro after down here at the end. So after everything's done, it'll execute these macro commands, and the macro command we want to execute is the export command. So we'll export this value of V to the file v.dat that's in that same folder. And one really nice thing about this approach, again, is that I can pretty easily test if this is working right away, right? So I know there is a file called state.dat that lives in this folder, so I can now just test this EES file. I'll just solve it just the same way that it's going to solve when Excel tells it to solve. And it opens the state.dat file, calculates and writes the v.dat, and if I go look at the v.dat file, you can see it contains the value of the specific volume. So now that's all ready to go back to Excel and open this and return that number. Alright, so returning to our volume function in Visual Basic, we're going to first of all use a FindWindow command to get a handle to the open EES file. So we already have to have EES open. It's all loaded up with the file that we want to run. So all Excel is doing here is just getting a handle to that program so that it can tell it what it wants it to do. If the handle comes back as 0, then it couldn't find an open instance of EES, and in that case probably we should issue an error message and we'll return a value of minus 999 just as a flag that it didn't work, and we'll exit the function. But otherwise, what we want to do is send EES a bunch of commands, right? And the first command is going to be to delete the EES call from app.log file. So you can see that command here. If you don't delete the log file, it'll just keep appending commands to the existing log file, which is fine. Maybe that's what you want. And then we will also turn on the log file. So we'll make sure that the logging is turned on. And then we'll issue the SendMessage command that tells EES to solve. Okay, and this will do exactly what we just did from EES, right? It's going to import the data from state.dat, calculate v, and then save it in v.dat. So all that's left now is to have my function in Excel open the v.dat file and return the number that's stored in there. So the SendMessage command itself returns a parameter, and we should check and see if that parameter is 0, because if it's 0, that means the command succeeded. We didn't encounter any errors. Otherwise, it will contain a string that has an error message in it that we should probably display. So if the result is not 0, then we're going to put up a message box that shows that error. But otherwise, if it is 0, then everything happened the way we thought it should happen, and we will call a function that we got to write called getOutput. And this getOutput function is going to open that file and retrieve the number that's inside. First, it's going to create a string called output file that holds the name of the file that we're going to open. Then it checks that the file actually exists. So if it doesn't, then it's going to issue an error message and again return minus 999 just as a flag that something went wrong. If the file does exist, then it's going to open the file, it's going to read the number, and close the file. And finally just return that number to the function volume, which then of course returns that number as the output of the function. So that should be it. We can test the whole process. So I'll go back to the spreadsheet and I'll just call that function volume again, and you can see that it returns the specific volume calculated by EES. And because EES is open and waiting, it's relatively fast to do this over and over again. So if I want to, maybe I can calculate the specific volume for a whole range of pressures. So let's just vary the pressure, and we'll keep the temperature the same and the refrigerant the same. And then here I'm just going to copy this function and evaluate it at each of these pressures. And you can watch each time that EES is called, and you can see that column just get filled in row by row.